Alright, my set of new keyboard stems is finished printing, and if I run through this with the focus, you can see all the little hairs on them that I was talking about, and again, that's most likely because my filament is moist right now. So let's go ahead and get these off and take a look at them. I've never printed a quantity of something before, so this is a weird new thing for me. So they're all individually stuck to the print bed still, but I think if I and all that's left on here is my little trace that it runs around called a skirt to prime the nozzle. And there we go, ready to print again. Which I'm actually going to be doing again immediately because I had a couple of design ideas that I want to try before I put all these in. So the first one has 2 slots near the tab, and I want to drop that back down to 1 like the originals had, although the originals also had some over actually on the other side that would give this more area to move. But I have already broken off some of the tabs on these, and that tells me that they're a little too fragile, so I want to do that. And then I've also eliminated the flat plane on the top here, and I want to see if I can make these removable from the top, so you can service the keyboard without needing to desolder every single key all over again. Alright, so this is the second switch design. Now, this can be pulled out from the top because it is beveled on both sides of the tab, so it's serviceable without needing to desolder the computer. Go ahead and realign that, and it works just fine, like the previous one. It has just 1 slot, like I mentioned, so it's a little bit stronger. Unfortunately for these, something was really kicking my Raspberry Pi's butt that was running the printer, and it kept stopping, leaving little dots all over the print, so these particular ones have to be filed quite a lot to be usable. But once they have been filed, they work very well, and I really like the idea of being able to pull them back out from the top. Well, we'll let you have the ability to file them down more if one isn't quite going to your liking, or just replace it with a new printed one. So I guess I get to print another 100 key switches. At this point, it's been about a week since I started working on this, and I've redesigned the key stem several times now. So here we have the original one, which we can see has 1 slot here, and then there's actually 1 slot on the side as well. And I tried to mimic that with 2 slots here because I know the PLA is fairly brittle and likes to snap, so I was hoping the strain going up higher would allow it to bend a little bit. But they did still end up snapping when they were put into keys anyway. So I tried to reduce this down to 1 piece. I changed using this black plastic because it's a brand new spool, and I thought it would have less stringing. But I didn't have settings dialed in for this one yet because it was a new brand for me, and these ended up being pretty brittle, so this part would snap off all the time. So I decided to go back to the stringing plastic, get rid of the strain reliefs altogether, and then just reduce the height of the bite that keeps the key stem in. This means that it doesn't need to bend as much to be installed. Now this is still the design I had last mentioned, where it is now beveled on both sides so the key stem can be removed from the front. You might be noticing the hole right here, and there's actually holes on all 4 sides of this print. That happened because I tried to reduce how long it would take to print these and to make them a little bit stronger. I changed my slicing settings so each wall on the side of this is only 1 layer of print, so the print head only goes past 1 time. That worked out really well until it got to this point where the internal structure is, and then it would kind of mess up with the bar going across and the triangles in the corners. It didn't come out that pretty. So I found a best of both worlds here, where I was able to trick it into printing 2 layers in the middle, but only 1 layer for the straight segments. These are now the pieces that I will be installing on all the key stems. The only downside is that in some of these, see if this one has it, yeah, right here, you can see right here that the slicer did put a bit of extra material. I didn't see that show up in the slicer, so I'm thinking it might be the seam where it started each layer. There's a setting you can change to have it randomize where it starts, and that may have fixed that. Or it could have just spread it all around and made it a bigger nightmare to try and file away. I'm not sure. At this point, I'm done doing testing, and I just want to get this finished. Now there's one final change I made for this, and it's not a change to the stems, it's a change to how these are installed. So if you see right here, we have the 2 metal contacts that make up the switch, and they have to be splayed apart to put the stem in, because the stem needs to have that divider go past. Now, if we look at this one, we can see an example of what happens when that goes wrong. The split in the stem didn't properly splay those apart. It ended up bending the tips of the finer side back and breaking them off. So in order to make sure that never happens again, I designed an install tool. So you put the flat side of the install tool against the finer fingered portion, drop the spring on, put the stem in place with it on the same side as the finer toothed one, and then slowly push it on. And then it will automatically spread the teeth apart so you don't damage it. Having redesigned the key stem did mean I had to print out a full new set of them. Well, I think it's time to start pulling off the keys and installing the new stems. This is going to take a really long time and to be very boring, so I'm just going to give you some progress shots along the way. Well, that's all the original stems removed. Time to put in the printed ones. And that is the numpad completed. Now I have to do the rest of the keyboard. And here's all the keys on the numpad, and they all seem to work just fine. Wow, look at how badly splayed E was on here. I can't believe this key wasn't constantly getting stuck. Here's the pile of all the old stems. Well, I guess it's still missing some that I have to take out of this one, but that's the bulk of them from the numpad and the main keyboard. Now to finish up putting these in, and I'll be a lot closer to done. Alright, there we go. All the new stems are installed and feeling good. Time to get the keys back in and try it out. I should mention that I haven't designed a replacement caps lock piece. Because it locks in the down position using this mechanism down here, it's a lot more complex. And it's not likely to be broken because people don't need to push this all the time. So for now I'm just going to go ahead and ignore that piece. There's one more piece made of that brittle white plastic, but it doesn't move and it's pretty sturdily designed, so I'd be really surprised if it was broken in anyone's keyboard. And here's the keyboard with all the keycaps reinstalled. Working just fine. Alright, every single stem in the keyboard has now been replaced with a 3D printed counterpart. Now I just have to solder it back into the PCB, reinstall the keyboard, put the case back together, and then we can try it out. This is a much longer project than my usual ones. It's really convenient that all the key blocks are held in place with screws, because it's going to be really easy to fly through and solder everything now. The keyboard is complete. Now I need to get the computer reassembled and test this. I'm going to do a partially assembled test first in case the keyboard doesn't work right, so I can get to it a little easier. Monitor, computer, got computer light. Come on, cursor. Okay. So, alright. Let's try all the keys. Here we go. Alright, so it's G and this period. But everything else is working great, so But it's only 2 keys tells me that it's not a problem with the ribbon cable that didn't come out terribly cleanly. Oh, there's G. Alright. Interesting. So, G's just gonna work now. Okay. Maybe something fell in between the contacts. Period. Ah, okay. There we go. Hit it a bit more vigorously, and something fell out. On some of the key stems, the lip didn't print well because they print flat, and the nozzle kind of pressed it in a little bit too much and flattened it out. The lip is supposed to be beveled on the inside, so the key can just slot in a little easier. So when it wasn't beveled, the material just kind of, it went in too far, so it gets stuck down in there. So I think that there may have been a little bit that got pushed through, kind of like that piece is hanging out. That was in there, but now it's working great. Now that the computer is repaired and the keyboard's happy and it's cleaner, I think it's time we play with it a little bit. So we're going to put in an example from the operating and basic programming manual. We're going to graph tan of x divided by 10. So we're going to have to type in this code here, and we're going to graph the result. So let's get started. Alright, so here's our code. Let's go ahead and run this. This thing is too cool. This is a good demonstration of one of the things that makes the HP80 series so cool. They're similar to the Commodores in that they have alpha memory and graphics memory. And we can take a look at page 29 here in the programming manual, and we can see that we have the alpha display here, which you can roll along on the screen, and we have the graphics display. Now you only have a set amount of memory in the computer, and you have to share it between these two. So now if we look back at the code we have in here, we can see at the very beginning we set graph all, and that sets all of the available memory to be used for the graphing capabilities. This lets us have the highest resolution display that we can possibly have. You can also set alpha all and have far more lines to be able to go through in the alpha memory. And that's cool because if I say scroll off screen, I can bring the data back. It's not just gone. Plotting doesn't even begin to scratch the surface of this computer's graphing capabilities, but we're not really going into a showcase of this computer in this video. There are a lot of other things that are really amazing about it. But for now, I'm going to leave it here. I've achieved my objective of creating new key stems for this keyboard, and it's fully functional. I'm extremely happy with how well this turned out. It's weird that I now have, like, a whole bunch of the original stems, and I'm not going to use them, but I'm keeping them because they go with the computer. I also have a whole bunch of the older design now, so that's fun. But it was so worth wasting all of that plastic to make it so I could pull these out if I wanted to. For those who don't have an HP Series 80 computer, I hope that was entertaining. And for those who do, definitely check out printing your own key stems instead of sacrificing a TI-99. These are technically the high-tech switches, and the TI-99s are the stack pull switches. So they are different, but mostly compatible. However, if you 3D print switches, you don't have to desolder two keyboards, because that's obviously not fun. I may offer some printed and finished key stems available for sale. It just depends on whether or not there's any interest. Leave a comment down below if you would like to just buy a set from me instead of have to print them yourself. I suspect there's not a lot of demand out there, so I wouldn't keep inventory on hand if I was going to try and sell them. But for now, that's everything I wanted to cover. I'll see you guys next time.